Lesson 2.5, simplifying nth root radicals. What is an nth root radical? Well, they're using the letter n to represent any number. And so these could be a radical with an index of any number. So it could be a 4th root, a 5th root, a 21st root, a 50th root, whatever they want to put. Okay? So we need to focus on two things. First of all, listing the perfect fourths, but then we'll get into ones that are bigger than the 4th roots. Okay? So on your sheet, you should see these, but I want you to think about if I had 1 times 1 times 1 times 1, that would be 1. If I had 2 times 2 is 4 times 2 is 8 times 2 is 16 would be the next. And then we'll do 3 times 3 is 9 times 3 is 27 times 3 I think is 81. Okay, now I'm going to start cheating. 4 to the 4th power is 256. 5 to the 5th power is 3,125. I'm going to stop there. These numbers get so big so fast, you never really see them get higher than this. Okay, but something I do want you to think about is when you're taking something to the 4th power, it's squaring something and then squaring that number. So like for example, 2 to the 4th power is the same as 2 squared squared. 2 squared is 4. 4 squared is how we got the 16. 3 squared is 9. 9 squared again is the 81. So it's like squaring a square. Okay, so we're simplifying each radical completely. This one's pretty easy. We've learned that we take the power divided by the index. So we'll take x to the 20th divided by 4, which would be x to the 5th. Then number 2, we have the 4th root of 81. Well, that is on our list, and we could write them that this is 1, 2, 3, 4, and 5. So the 4th root of 81 is 3. 8 divided by 4 is 2. So that simplifies just to 3x squared. Number 3, we have 4th root of 256. That's on our list. That is just regular 4. And 24 divided by 4 would be 6. Go ahead and pause and do number 4. 4th root of 16 is 2. 12 divided by 4 is x cubed. Okay, so that's those. They all come out nice and neat, I think, on Delta Math as well. The next ones, we're dealing with just variables. They have no coefficients, which is nice. We've got 5th root of x to the 21st power. We need to have multiples of 5. So I'm going to break this into x to the 20th, and then times, well, we would need another x to make 21. X is getting multiplied together. So this is a 5th root and a 5th root. 20 divided by 5 would be x to the 4th times the 5th root of x. Right, number 6. How many groups of 6 can I take out of 11? Or think of what's the closest, not the closest, but going down to the next multiple of 6 would be x to the 6th. And then left over, I would have 5. Because 6 plus 5 would make the 11. This is actually just canceling. 6 divided by 6 is 1, so it would be x to the 1st power, or x, times the 6th root of x to the 5th. Okay, why don't you pause and try 7 and 8. Check your answers. Number 7, you can only take out an x to the 7th, and you have left over x to the 4th, so this would cancel, just make x to the 1st, and then times 7th root of x to the 4th. On the 88, you could take out or go down to 81, because 81 divided by 9, or 9 times 9 is 81. And so we'd have x to the 9th, and then a 9th root of x to the 7th left over.